In this lesson, we are going to look at arithmetic and geometric progressions. So a revision lesson, so I'm going to go into question right away. And as usual, I'm using New General Mathematics SS3, the revision part. So if you have the textbook, you can open to the revision part and follow along and solve some question on your own also. So the first question here says, find the sum of the first 13 terms of the arithmetic progression 5 plus 8.5 plus 12 plus ... The dot means the sequence continue. So we have to find the sum of the first 13 terms of the arithmetic progression. For an AP, the sum of nth term, which is Sn, is given by n over 2 multiplied by 2a plus n minus 1 times d. So in this case, we have to find the sum of 13 terms. The first term of this sequence, which is denoted A, is 13, is 5 rather, 5, and D is a common difference. The common difference is the difference between this term and this term, or the difference between this term and this term. That will be 8.5 minus 5, which is 3.5. 3.5. And Sn, which is S13, n is 13 because I say we find the sum of the first 13 terms. 13 divided by 2 multiplied by 2 times a is 5 plus 13 minus 1 times the common difference, which is 3.5. That will be 13 divided by 2, which is 6.5, multiplied by 10, that is 2 times 5, plus 13 minus 1 is 12. 12 multiplied by 3.5, which will be 6.5 multiplied by 10 plus 12 times 3.5. Let me convert this to improper fraction first. 12 times 3 times 2 is 6 plus this 7, 7 over 2. 2 here 1, 2 here 6. I'll have 6.5 multiplied by 10 plus 6 times 7 is 42, and 42 plus 10 is 52. So 6.5, let me turn it back to 13 over 2. 13 over 2 multiplied by 52, 2 here 1, 2 here 26, and 13 times 26 will be 13 times 26, 338. So the sum of the first 13 term of this sequence is 338. The sequence is an AP, 338. The sum of the first 13 term is 338. For question 35, the question says the first and last term of an AP are 79 and negative 5, and its sum is 814. Find A, the number of terms in the AP, B, the common difference between them. So A, according to the question, which is the first term, is 79. The last term, denoted by L, is negative 5. Then the sum of the terms of the sequence Sn is 814. For a sequence whose last term is given, as in this case, the sum of the term is given by n over 2 times a plus l, where l is the last term of the sequence. So if we substitute all of this into this, I will have 814 equal to n, which is what we are looking for, the number of terms, over 2 multiplied by 79, the first term, plus the last term, which is negative 5. This will be 814 equal to n over 2 bracket 79 plus times minus is minus 79 minus 5. So 814 is equal to n over 2 multiplied by 79 minus 5 is 74. 2 here 1, 2 in 74 is 37 or so. So 814 is equal to n times excuse me, 37. 814 therefore is 37n. N equal to 814 over 37. 814 divided by 37 is 22. So the number of times in this sequence is 22. That is question A. Then question B say the common difference between them. Excuse me. Common difference between them. For a sequence like this, whose last term is given to us, the last term of a sequence, L, is given by the formula A plus n minus 1 times d. And L is negative 5, so negative 5 is equal to 79, that is A, plus n, which we just calculated to be 22, minus 1 times d. Meaning negative 5 is equal to 79 plus 21 minus 1 is 22 minus 1 is 21. 21 times d is 21d. Taking 79 here, that will be minus 5 minus 79 equal to 21d. Minus 5 minus 79 is minus 84 equal to 21d. D therefore is minus 84 over 21. And 84 divided by 21 is 4. So our answer is minus 4. The common difference is minus 4. Then question 36 says, in an arithmetic progression, the third term is 1 and the fifth term is negative 3. Find the common difference and the first term. So in the third term of a sequence, a linear sequence or arithmetic progression is A plus 2D. According to the question is equal to 1. The third term is 1. Let's call that equation 1. Then the fifth term of an arithmetic progression is A plus 4D equal to negative 3. Let's call it equation 2. How did I get all of this number? There's a full tutorial on sequences in the description of this video. You can go and take it if you don't know how I got this. So these two form a simultaneous equation. So if I solve these two equations simultaneously, I'm using elimination. I am eliminating A by subtracting equation 2 from equation 1. A minus A is 0. Then 2D minus 4D is minus 2D equal to 1 minus minus 3. Look at the 1 minus, then minus 3. That will be 1 plus 3, which is 4. So I have 4 there. Meaning D will be 4 divided by minus 2, which is minus 2. So if D is minus 2, we can solve for A using any of the equation. Solving for A using equation 1. Equation 1 says A plus 2D is equal to 1. That means A plus 2 times D is negative 2 equal to 1. A minus 4 equal to 1. A equal to 1 plus 4, which is 5. So if A is 5, Okay, that is what they ask us to find, the common difference and the first term. The common difference is 2, -2 rather, and the first term is 5. Question 37. So find the sum of the following GPs. For a geometric progression, the first term A, according to this sequence, is 2 there. Then the common ratio R will be the second term divided by the first term, or the third term divided by the second term. So, and so it goes like that. So 10 divided by 2 is 5. Then we have to find the sum of the GP. The last term is given. The last term of a GP is A R to the power of n minus 1. And according to this is 1250. If that is the case, we know A to be what? 2. 2 times R to the power of n. I know R to be 5, so 2 times 5 to the power of n minus 1 equal to 1250. Dividing both sides by 2, so I can clear this 2 here. By 2, I have 5 to the power of n minus 1 equal to 1250 divided by 2. That will be 625. 625. Expressing 625 in index form so that the bases can be equal. The bases, here I have 5 to the power of n minus 1. I want to express this in 5 to the power of something also. 5 to the power of 4. So 5 to the power of n minus 1 is equal to 5 to the power of 4. The bases are the same, so we can equate the power, meaning n minus 1 is equal to 4. N therefore is 4 plus 1. N is 5. So we have known n, we know A from the question, A and R from the question, so we can find the sum of the GP. Now there are two formulas for calculating sum of GP depending on the value of R. If R is less than 1, the formula is Sn equal to A multiplied by 1 minus R to the power of n over 1 minus R. This is for R less than, 1. On the other hand, if R is greater than 1, the formula becomes A multiplied by R to the power of n minus 1 over R minus 1. This is for R greater than 1. So in our question, R is greater than 1 since R is 5. We are going to use this formula to find the sum of this sequence. So that Sn for this sequence will be A. What is A? A is 2 multiplied by R is 5. 5 to the power of n. N is 5. 5 to the power of 5, then minus 1. All over R again. R is 5 minus 1. So that will be 2 times 5 to the power of 5 is, I think, 3125 or so. 5 to the power of 5 is 3125 minus 1 all over 5 minus 1 is 4. I will have 2 times 3125 minus 1 is 3124 divided by 4. 2 here 1, 2 here 2. 3124 divided by 2 1562. 1562 is the sum of that first sequence, and the sum of the second one. Let's move this thing down so we have space to work. For the B part, A is equal to 1, and then the common ratio R is negative half, which is the second term, divided by 1. Negative half divided by 1 is still negative half. But this one, they want us to find the sum as far as 1, the system, and 2, the infinity. So we need to find the system and then the sum to infinity. So in this case, since R is less than 1, we are going to use the formula that's Sn equal to A bracket 1 minus R to the power of n over 1 minus R, because here R is less than 1. So sum to the system first, not sum to infinity. The system S6 will be A, which is 1, bracket 1 minus R is minus half, then to the power of n is 6, all over 1 minus, what is R? R is minus half. So here we have 1 times 1. Now, when a negative number is raised to an even number, the negative will become positive. So minus half to the power of 6 is plus. And 1 to the power of 6 is 1. 2 to the power of 6 is 30. I think 30, no, 64. Let's confirm that. 2 to the power of 6 is 64. 64 all over 1 plus minus times minus is plus. 1 plus half. So here we have 1 minus 1 over 64. This is 1 over 1 and 1 over 64 all over 1 plus half. Solving this fraction, I'll have 64 minus 1 over 64 all over. Again, solving this fraction, I'll have 2 plus 1 over 2, which is 64 minus 1 is 63 over 64, and divided by 2 plus 1 is 3 over 2, which it can become 63 over 64 multiplied by 2 over 3. When one fraction divides another fraction, the sign of division will change to multiplication. They will multiply by the reciprocal of the second fraction. 2 here 1, 2 here 32, 3 here 1, 3 here 21. So we have 21 over 32. So our answer here, 21 over 32, is the sum of the system to the system of this GP. And let's move on to the sum to infinity. The sum to infinity of a GP, which is denoted by this, is A over 1 minus R. The sum to infinity, what is A? A is 1, and 1 minus R is minus half. This will be 1 over 1 plus half, which is 1 over 1 plus half is 1 and a half, which is the same thing as 3 over 2, and this will be 2 over 3. So the sum to infinity is 2 over 3. And we have some WAEC questions here, past questions. First one says, The sixth term of an AP is 35 and the 13th term is 77. Find the 20th term. Sixth term of an AP is A plus 5D. According to the question, it says 35. Let's call that equation 1. The 13th term is A plus 12D. According to the question, is equal to 77. Let's call that equation 2. Solving 1 and 2 simultaneously by elimination, A minus A is gone. 5D minus 12D is 7 minus 7D equal to 35 minus 77. 35 minus 77 minus 42. D will be minus 42 over minus 7, which is 6. Now solving for A using equation 1. Equation 1 says A plus 5D is 35, meaning A plus 5 times D is 6. It's equal to 35. A plus 30 equal to 35. A equal to 35 minus 30, which is 5. But the question says we should find the 20th term. T20 for a linear sequence of an AP is A plus 19D. A is 5. 19 times D is 6. So we have 5 plus 19 times 6 is 114. 5 plus 114 is 119. Finally, the last question says, the first and third terms of a geometric progression GP are 2 and 2 over 9 respectively. Find the common ratio and the fifth term. The first term A is, according to the question, the first and third terms are 2 and 2 over 9 respectively. So A is 2. A is 2. While the third term of a GP is AR squared. Is equal to 2 over 9. But A is 2 right here. So 2 times R squared is equal to 2 over 9. This implies that R squared is equal to 2 over 9 divided by 2 and divide both sides by 2. Which means R squared equal to 2 over 9 multiplied by 1 over 2. R squared equal to 1 over 9. Which implies R is equal to square root of 1 over 9, and square root of 1 over 9 is 1 over 3. So if R is 1 over 3, we have to find the common ratio, which is 1 over 3. And the fifth term of the GP is AR to the power 4. A is 2, R is 1 over 3. 1 over 3, then to the power of 4. That will be 2 multiplied by 1 to the power of 4 is 1. 3 to the power of 4 is 3 to the power of 4, 81. 1 over 81, which is 2 over 81. So the fifth term is 2 over 81. That brings us to the end of this tutorial, this revision.